Alright, so 8.2 deals with quotients of exponents. So yesterday with 8.1 we did products, today quotients. 8.2 starts on page 333, so let's go ahead and start with a lesson opener. So if you think all the way back to chapter 1, you should hopefully remember that when we are dividing terms with exponents, we subtract the exponents. So for this, this is like x to the 5 minus 2, we're subtracting those exponents, and we get x to the third. In this case, be like x to the third divided by x to the third, or we do to the third minus the third, which would be x to the 0. Anytime anything is taken to the 0 power, it is always equal to 1. Or we can just always go ahead and look back and say, well, anytime I divide something by itself, I know I'm going to get 1. And then you might not be quite as familiar with these, but whenever we have a coefficient out in front, we have to divide the coefficient and then subtract our exponents. So we'll end up with 6 divided by 3 is 2, and 7 minus 5 is 2, so y to the second power. A little bit more on our opener. Just remember, we can't actually cancel these out because it's being added, our y squared is being added to something else. So unless we were able to cancel both sections, it's just not going to work out. So this is actually already simplified. And the last one, hopefully you remember when you see a negative exponent, you flip it up, whether it's on the bottom, you flip it to the top, or if it starts out on the top, you flip it to the bottom. So 1 over x to the negative second power is x to the second power. So that brings us to our quotient properties for exponents. And it's just like what we were just talking about here. Whenever you are dividing exponents, or you're dividing with exponents, and you have the same base, you just subtract the exponents. And then negative exponents, remember we said if it starts out a negative, this would be like it's already in a numerator technically. You flip it to the denominator, or vice versa. So if you have trouble still with negative exponents, go ahead, check out a video on Khan Academy about negative exponents, because that'll give you a second to go ahead through and just review why that actually happens. So we are actually skipping example 1 because it is just like the third warm-up we did, just different numbers. Let's take a look at example 2. So we are simplifying what looks to be this big mess, but once you break it down a little bit at a time, it's really not too difficult. This is where it's really helpful to make sure your variables are all in alphabetical order so they're easily identified. So first things first, we have our coefficients. 24 divided by negative 8. Well, 24 divided by negative 8 is negative 3. Next up, we have our x squared divided by x. Well, that's like x to the second minus 1. Then we have our y's, y to the 6th divided by y to the second. So we'll subtract those exponents. And z to the 7th divided by z to the 5th, we'll subtract those exponents. So we're left with negative 3 times x times y to the 4th times z to the 2nd. And that would be our final answer there. So just like we were saying earlier, whenever you have a negative exponent, if it starts out in the numerator, you flip it down to the denominator. Likewise, if it starts out in the denominator, you flip it up to the numerator. So if we had a to the negative second, it would be equal to 1 over a to the second, and 1 over 5 to the negative second would be equal to 5 to the second. Like I said again, we did this in chapter 1, so if you're still a little fuzzy on why this actually happens, just go back and check out a Khan Academy video, or I even have the chapter 1 recorded if you'd like to see that, the actual text version of it. But you can just Google negative exponents in Khan Academy and they'll give you a quick video to watch so you can remember why that actually happens. So in example 3, we have 4 different problems in example 3. First one says x to the negative 4th times y to the 2nd well, we have a negative fourth, so it's going to go down and be 1 over x to the fourth times y to the second, and then we just multiply straight across to finish simplifying these. So there's an imaginary 1 over there. We just multiply 1 times y squared and x to the fourth times 1. We end up y squared over x to the fourth. So remember, since there's no parentheses, this power is just attached to the x, so that makes it 2 times 1 over x squared, Then you just multiply straight across. We end up with 2 over x squared. For c, this time it is in parentheses. That means we're going to have to apply the third power to the negative 3 and the third power to the x to the negative second power. We have to remember that whenever we are taking a power to a power, we're multiplying those exponents. And then we should always go ahead and do the math. So this is like negative 3 times negative 3 times negative 3, which will give us negative 27. And then x to the negative 6th. We need to get rid of that negative power. And we end up with negative 27 over x to the 6th. And last, we have example 3D, which is 1/3 times x to the negative third taken to the negative second power. So this time, we're just going to apply this here, apply that there. So when we take 1/3 to the negative second power, that's the same as saying 3 to the second power. And then we have negative 3 times negative 2, which will be 6. We should never leave the coefficient to a power. We should go ahead and just work that out, do the math. So 3 times 3 is 9. We have 9 times x to the 6th power. So these were the quotient properties, and then the negative exponent property. We already talked about those. The last one we need to remember is our zero exponent, which we touched on at the beginning of this lesson also. And that's just any time any number is taken to the 0 power, it is always equal to 1. So example 4. Example 4, if you look at your book on page 334, is a really long, it says divide 3/4 times x to the negative third times y to the second times z to the negative fifth by negative 18 times x to the negative 6 times y to the second times z to the negative second, which is really long. Express the answer in positive exponential form. So the easiest thing to do is just go ahead and write that out as a fraction. So that way we're kind of lining everything up and we can see what we're working with. And you have to remember this would be like the 34 and all that divided by negative 18, so you have to make sure you put them in the right order whenever you're reading your problem out. So we'll break it apart one chunk at a time. So 34 divided by negative 18. Then we have our x's. Remember, we're subtracting, so negative 3 minus negative 6. Y to the second minus 2. And then our z's, again, we're dealing with negatives, but we're subtracting, so it'll be z to the negative fifth minus negative 2. We have to remember whenever we are subtracting a negative, that's the same thing as adding. Does 34 over negative 18 reduce? Yes, it does. It reduces to negative 17 over 9. We can reduce each of those by 2. Then we have negative 3 plus 6, so we have x to the third, y to the 0 power, because 2 minus 2 is 0, and z to the negative third, because negative 5 plus 2 is negative 3. And then we just have to say, okay, well, where did each of these go? So we don't necessarily want to have negative exponents. So that's positive, it's going up. 0 is technically positive, it's going up, and our negative will go down. So we have negative 17 times x to the third times 1 over 9 times z to the third, but we know that anytime we multiply a quantity by 1, it just remains the same, so we can actually drop this 1 out of there. It just becomes negative 17 x to the third over 9 z to the third. So the power of a quotient is equal to the quotient of the powers. This is very similar to what we were talking about in 8.1 whenever we said like the quantity a, b, c to the n is equal to a to the n, b to the n, c to the n, same sort of deal. So we're just having to take that n, we're applying it in both places. So a to the n over b to the n. Example 5. Simplify, and then it gives us what to simplify right here. Leaving all variables in the numerator. So this time we will end up probably with negative exponents, but because they said leave everything in the numerator, it's okay to have negative exponents. So we'll just go ahead and work through this one step at a time. First things first, we're taking quantities to a power. So we'll have to apply this to both places and apply this to both places. So we end up with y to the third. Remember, when we multiply, or we take a power to a power, we multiply the powers, so x to the sixth. Same thing here, we're taking powers to powers, so we're multiplying. So this is where we have to be careful because it's not all nice and organized for us like we're used to. So you can kind of just picture all this over one as well. We need to find our x's first, so we'll have x to the sixth over x to the sixth. And then we have y to the third times y to the negative 8. So when we have x to the sixth divided by x to the sixth, we're subtracting those powers. When we have y to the third times y to the negative 8th, we're adding those powers. So 6 minus 6 gives us x to the 0. 3 plus negative 8 gives us y to the negative 5th. Well, we already said whenever we take a quantity to the 0 power, that gives us just 1. It's like saying multiplying by 1, which means we can drop that out and it's just y to the negative 5th. And we can leave that as our final answer because they told us it's okay, go ahead, leave all the variables in the numerator. So that would be our final answer. So an expression containing negative exponents in the denominator is not considered to be simplified. It's generally preferable to use only positive exponents in a simplified expression, which means we don't want to leave it the way we left it in example 5. They let us do that this time, but it's generally just not something we should do. So go ahead finally and take a look at example 6. And let's go ahead and do example 6 together without the slide animations. So first things first, we want to go ahead and pick out each chunk. So we have some coefficients. So that's like a negative 2 times a negative 3. Then we have some x's. Oh, I'm sorry, and we should say there's a 12 down there too, so we should say that's all over 12. Then we have some x's. So we have an x to the negative second times an x to the first, so that's like saying plus 1. And then we have y to the negative second over y to the third, so it's like saying minus 3. So negative 2 times negative 3 is 6 over 12. Which is also equal to 1/2. We'll come back and fix that in a second. Then we have x to the negative 1, and we have y to the negative 1, 2, 3, 4, 5. And finally, we can combine that all, so we can say we have 1/2, that x is on the bottom, and our y to the 5th is also on the bottom, so we have 1 over 2 times x times y to the 5th, and that's our final answer. Now there was a part B to example 6, so go ahead and try that one on your own because we're just about out of time. I'll flash up the answer here whenever we're all done. But go ahead and check out your assignment then, let me know if you have any questions. And then last but not least, here is example 6B worked out. They actually did it 2 different ways. I did it the first way. You might have done it a little bit differently, but just so you end up with the same final answer. So check your work, see what you did. Let me know if you have any questions.